Hello, dear students. We have discussed about electromagnetic induction EMI in the some introduction type video of the previous class. You know well about electromagnetic induction at the point where we were considering that a magnet, and this is the loop, conducting loop. Now the magnet is moving along this side. The magnetic field lines through this loop is increasing. You can say that magnetic field lines. Here induced EMF is developed, and I have already discussed the cause of this is the reaction, that is the Lorentz force QE QV cross B. And here this is the force on free electrons that are available in conductor. And to avoid this force, there is an electric field set up and developed. When we along the direction perpendicular to this V and B and V dot dr, according to this dot product, that is force को minimize करें, that is 0. So that is the E dr, and along this side is move to this, and this will be equal to flux change. And we cancel this charge Q, if is 0, that Q will be cancel out in 0. And this term Q V cross B dot dr, because we know that this is the flux, and this flux change in the direction perpendicular to V and B, both. Suppose V x-axis, B y-axis, then the dr will be along z-axis, and z-axis is the dot product, and this EMF is developed along z-axis. It is very simple to understand that this is called the negative rate of magnetic flux change minus dV. We can say that dV equal to minus V cross B and dot dr. This is the negative rate of change of magnetic flux, that is induced EMF. Okay, and this is perpendicular to both the velocity and the magnetic field. The velocity is set up in such a direction that it can minimize the magnetic force on it. So it develops an electric field, and this electric field across the length, across dr, develop EMF, electromagnetic force, that is called inductive induced EMF. Okay, this is the basic of this electromagnetic induction, the simple thing. Okay. And the direction we can find this simply according to Lenz's law. The EMF cause, what is the cause of EMF? Change in magnetic flux, and this induced EMF is set up in such a way that it can oppose the change of magnetic flux, due to which cause the induced EMF is developed. It opposes it. Okay, direction is set up according to to oppose the change in magnetic flux through any link, any conductor. Suppose we consider current. What should be the current in this loop? That current will be in such a way that it can develop a magnetic flux, induced current, in such a way that a magnetic flux due to induced current should be in this direction, opposite direction, because magnetic flux changing and increasing is the side. So this current will try to decrease this flux that could coming from right to left. Okay, and we can mention this current in such a way, any direction, but it's just a point to understand clearly. Induced EMF opposes the cause due to it is developed. Induced EMF opposes the cause due to which it is developed. What is the cause? Cause is the change of magnetic flux. Okay, this is the basic thing. Okay, then we'll continue completely this chapter, and I'll provide you all the lectures of this chapter properly. We carry on and subscribe the channels. Done? Sure.